Welcome to Dementia Matters, a podcast created by the Wisconsin Alzheimer's Disease Research Center. It's our goal to humanize Alzheimer's research so that our community, our patients, our participants, and anyone else interested can get a better understanding of the work that's happening to fight back against this disease. My name is Nathaniel Chin, and I'm a geriatric memory clinic physician at the University of Wisconsin. I'm also the family member and son of someone with dementia. I'll be serving as your host for this podcast and asking the questions I believe are in the minds of many in our community. Thanks for joining us. Today I have Dr. Sterling Johnson. He is a clinical neuropsychologist with a research focus on brain function in Alzheimer's disease and related disorders. He is the Associate Director of the Wisconsin Alzheimer's Disease Research Center and the Principal Investigator of the Wisconsin Registry for Alzheimer's Prevention Study, otherwise known as WRAP, which is the world's largest longitudinal research study on adults whose parents were diagnosed with Alzheimer's disease. Well, thank you for joining us today on Dementia Matters. We're very excited for this interview, Dr. Johnson.
Thank you. I'm glad to be here.
So let me start by saying the Wisconsin Alzheimer's Disease Research Center is well known for its research using biomarkers in preclinical Alzheimer's disease. But before I have you talk about that specific research, I have two very important questions. One, what are biomarkers? And two, what does preclinical Alzheimer's actually mean?
A biomarker is an indicator, a biological indicator, bio meaning biology, and marker is a measurement, some kind of test of the disease. We have biomarkers for other diseases, like we have a blood pressure cuff to measure high blood pressure, which could be an indicator of cardiac disease. The biomarker is something that's measurable and something that's relevant to the disease and helps us gauge the disease presence or its severity. In Alzheimer's disease, we are just now developing really focused biomarkers of the disease itself. The biomarkers we have are levels of proteins that in Alzheimer's may become abnormal. Other forms of biomarkers can be something like an image of the organ of interest, which in this case is the brain. Now, this is really important because Alzheimer's disease has a very long lead-in phase, and we call that the preclinical phase. Typically, when we think of Alzheimer's, we're thinking of actually the dementia phase of Alzheimer's disease. By the time a person gets to that point of dementia, their brain has already undergone years, if not decades, of gradual, subtle, but progressive change. And by looking at this phase of the disease that is prior to those symptoms, this preclinical phase, we think we may be able to find the disease earlier and then make the decisions that are in the best interest of those participants and patients.
And so then you also touched on, I think, a very important part, which is that there are multiple ways to look at a disease and therefore multiple biomarkers.
Right.
And so you had mentioned the protein, but the protein itself can be measured in cerebral spinal fluid, which we obtain through a lumbar puncture. But what other ways can we look at any variety of biomarker?
For Alzheimer's disease in particular, we're interested in the brain. So anything that gets us to the brain in the living patient is a potential biomarker. Biomarkers are usually more indirect, and the cerebral spinal fluid is a really important methodology because that fluid bathes the brain, and any of the proteins that the brain sheds out of its system during the day are accumulating in that spinal fluid. And so that is an important fluid to assess different levels. But the other important biomarker that we use is images. There's many different types of brain images, and brain imaging is a way of understanding things like brain health, brain function, and more recently, some very useful techniques that we think will be the biomarkers of the future. These new techniques are from a method called positron emission tomography, PET for short. And with PET, we can actually detect the amyloid plaques and the neurofibrillary tangles that are the hallmark features of Alzheimer's disease.
Why are biomarkers so important to Alzheimer's disease research?
It's important for us in several ways. I think the most useful way is going to be identifying how this disease is progressing prior to symptoms. So it's going to be hopefully useful for making a diagnosis, a more accurate diagnosis, and then potentially helping us monitor the pace of disease progression and whether that pace of progression can be slowed by some form of treatment.
It's my understanding that at least the current clinical trials have not shown success in people who've already been diagnosed with clinical Alzheimer's disease. And so the feeling, or at least the direction, is that we should be looking at this preclinical. And in order to get preclinical, we need these biomarkers. Is that right?
That's exactly right. We often think of Alzheimer's disease as the dementia stage. This is the stage where cognition is impaired. We have deficits in memory and something called executive function, our ability to navigate in the world. And these deficits in memory and executive function are really responsible for the main symptoms and problems that we see with the dementia phase of the disease. But the brain is a really resilient organ, and it has the ability to tolerate and accommodate these amyloid plaques and neurofibrillary tangles for years. And as these things accumulate over time, eventually the brain can no longer tolerate it, and that's when the symptoms begin. So if we have a marker of these pathologies, of the neurofibrillary tangles and the amyloid plaques, we can detect this disease while it's still in that resilient phase and maybe postpone or prevent the onset of those symptoms as the treatments come along.
Well, in my clinic, I often talk to people about inflammation and blood flow in the brain.
Mm-hmm.
A lot of the community members know about these more fancy brain images of PET scans and some of the lumbar puncture studies. But the common question is, do we have a way of looking like a biomarker at blood flow or inflammation in the brain?
We are developing those techniques. There's new methodologies that are being developed here at UW to assess blood flow. And we partner with them, and we're assessing the usefulness of these new techniques in patients who have Alzheimer's or other diseases. So yes, there's some promising methods on the horizon for blood flow. And this is important because there's new research to suggest a link between blood flow and the brain's ability to clear out the amyloid plaques and the neurofibrillary tangles. And we also know that these pathologies, the plaques and the tangles, are not good for the brain in a local sense. And what I mean by that is they can cause irritation and inflammation of those neurons that they are neighboring against. And that inflammation also impedes the clearance of the amyloid plaques and the other metabolites that the brain has daily. It kind of interferes with the irrigation system or the garbage collection system that the brain has in place. Gumming up the system in that way may exacerbate the pathology that accumulates with this disease.
Could you go back and kind of explain to us the role that imaging has played in the study and the diagnosis of Alzheimer's disease?
Imaging has usually been used clinically as a way to rule out other causes of cognitive decline. A CT scan was a way to just look at the brain's anatomy and make sure everything's okay and that there's no strokes or tumors that would account for the cognitive changes that the physician is observing. MRI has a very similar use in ruling out other causes of cognitive decline. So MRI and CT, for that matter, have developed rapidly over the years, and we've talked about blood flow. That's an important method that can be looked at with CT and MRI. But it's important to point out that MRI and CT scans are not diagnostic of Alzheimer's disease. They are not a useful biomarker of the amyloid and tau pathology that occurs in Alzheimer's disease because they don't measure amyloid and tau. They measure brain atrophy, they measure strokes, they measure brain connections. We can even look at brain function. Some of these things may be signs that disease is occurring, but there's nothing about an MRI scan or a CT scan that directly measures amyloid plaques or neurofibrillary tangles.
We do have a PET scan that is being used in the clinical world, and it's called an FDG PET scan, and it really looks at how glucose is being used. Could you explain this process?
Sure. The glucose PET scan is a way of detecting how metabolically active different parts of the brain are. Glucose is the primary fuel for the brain, and this FDG, or fluorodeoxyglucose, goes into the brain and it's taken up by neurons that are active and metabolically doing something of use in the brain, and that provides an image of brain activity of sorts. So this is a critically important technique. It's a spatial image of brain function, so to speak. But FDG, this glucose PET scan, is not a scan of amyloid plaques or neurofibrillary tangles. It's a scan of brain health.
And so with that, I'd like to end with this last question of what studies are being done right now at our Alzheimer's Disease Research Center that involve any form of biomarker.
We have a number of studies going on right now involving biomarkers. We have some clinical trials. The A4 study is being led by Dr. Carlson here. It's a national study. And that involves amyloid imaging in people who are asymptomatic, and they go on to get an experimental therapy. So that's an important biomarker study because the amyloid levels on the scans are being used as the major outcome of that study. We have several studies involving cerebrospinal fluid, and we have studies that are investigating tau and amyloid imaging in people at risk for the disease, some natural history studies. In RAP, the Wisconsin Registry for Alzheimer's Prevention, we're undertaking a number of studies looking at amyloid plaques and neurofibrillary tangles using these biomarker scans. We have one that's a study called ADNI, the Alzheimer's Disease Neuroimaging Initiative. This is another national, and indeed it's a worldwide study that is doing these imaging and CSF biomarkers together with advanced MRI and cognition measurement every couple of years.
Are any of these studies still enrolling people in the community?
We do have studies open to the community. The ADNI study is enrolling, and that's open to the community, patients with dementia, patients with MCI, and healthy older volunteers.
I'd like to thank you, Dr. Johnson, for coming on Dementia Matters, and we hope to have you on another episode.
Thanks. It's been great to be here.
Dementia Matters is brought to you by the Wisconsin Alzheimer's Disease Research Center. The Wisconsin Alzheimer's Disease Research Center combines academic, clinical, and research expertise from the University of Wisconsin School of Medicine and Public Health and the Geriatric Research, Education, and Clinical Center of the William S. Middleton Memorial Veterans Hospital in Madison, Wisconsin. It receives funding from private, university, state, and national sources, including a grant from the National Institutes of Health for Alzheimer's Disease Centers. This episode was produced by Rebecca Wazaleski and edited by Zoe Rugel. Our musical jingle is Cases to Rest by Blue Dot Sessions. Check out our website at adrc.wisc.edu. You can also follow us on Twitter and Facebook at Wisconsin ADRC. If you have any questions or comments, email us at dementiamatters@medicine.wisc.edu. Thanks for listening.